like nomenclature, okay? We have two different things that we can name them as. They're either covalent or ionic. So we have covalent bonds or we have ionic bonds. Now, the little thing that I told you guys to memorize the covalent bonds was what? C, N, N, pre-show. The reason is covalent is a non-what? Non-metal.
It has prefixes.
Non-metal compound, and you use prefixes. Do you have to balance it?
No.
No. So there's no balancing. Do you have an ending on any of these?
Yeah.
Yes. They get married, they become brides. The second element has what on the end of it? Element ends in I. Very good. There we go. All right, now the last thing that we're going to talk about for this, use prefixes, we don't balance it, it ends with I. The prefixes, if we're talking about those, the only prefix that we need to have something or we need to know something about is what? Mono. And what is that?
One.
It is one. But do we use it on the first element?
No.
We do not use it on the first element. Why not? You know? Okay, so we don't use it on the first element because of the reason we understand it. Do you say monocarbon monoxide or do you say carbon monoxide? Carbon monoxide. So put something in your mind when you're thinking about that. So there's the first question. Does it have a non-metal combo? And if it doesn't, or if it does, you use this. If it doesn't, we go into ionic. We know it's an ionic bond. Okay, so if it's an ionic compound, we know that it's got to have a cation and an anion mix, right?
Right.
Cation meaning positive charge, anion meaning negative charge. Okay? They can come in different ways. You can have them in our house metals, in our transition metals, and what else?
Our baby.
Polyatomic ions. Right?
Right.
And then anions normally are either polyatomic ions or what?
Or non-metals.
Or they're non-metals. Very good. So in order to figure out if it's a house or a transition or a polyatomic ions are always made of how many portions?
2.
There's 2 of something or there's multiples of stuff. Like O2 has only 1, but most times you'll see like a ClO3 or a BrO3, okay, those kind of things. So if you see 3 elemental letters already, you know all of a sudden it's already in the polyatomic ion zone. If not, you're going to look at your cation, and since you know that it's not a non-metal, you would have to figure out is it a transition metal or a house metal or a polyatomic ion. Now if it's a polyatomic ion, all you do is you name it exactly like it is. You name it exactly like it is. You don't put an "ide" on there. If it's a phosphate, you put phosphate. It's kind of like when I told you guys when they get married and become a bride. The polyatomic ions are like the rich doctors. The rich doctors, they keep their own last name. They don't change over to their husband. Okay? The transition metals and the house metals. The house metals are considered in the house because group 1 is like the mom. Group 2 is like the dad. Those are the ones that are positive 1 and positive 2 on the periodic table. Then you have the babies. I always say we have aluminum as a positive 3, the 2 twins, CD and ZN, which is a positive 2, and then AG, which is a positive 1. Okay? Notice they're all positive charges. The transition metals are anything else, and they're transition metals because they could either be positive 1, positive 3, positive 4, positive 5, whatever they may be the day of that you're looking at. So in this case, we put these as TR metals, and our TR instead of house, and the reason we do that is because we think transition, Roman numerals. Now, if we want to name those transition and Roman numeral metals, we need to know 2 things. Number 1, house. You can just keep off the phone. Or stop and go to the next one's phone. House. You stop. You gonna stop it?